Let's start with the security market line. Security market line is as follows. The expected return on security I, let's assume I is a stock, is equal to the risk-free rate plus beta on security I times, parentheses, the expected return on the market minus the risk-free rate. What does this mean? It's basically a way of telling us what we expect the return on a stock to be given a risk characteristic of the stock and what the market is expected to do. And we have a special name for this piece over here. It is called the market risk premium. In finance, we define a risk premium as the expected return on something minus the risk-free rate. In this case, the expected return on the market minus the risk-free rate is the market risk premium. Let's see what happens when we subtract R sub f from both sides. Now we have the stock risk premium is equal to beta times the market risk premium. And so now we can solve this thing for beta. Beta is simply equal to the stock risk premium divided by the market risk premium. What if we were looking for the expected return on the market? Well, we could start with this equation we have here. We're trying to get the expected return on the market by itself. And we're going to go in reverse order of our order of operations, which means the first thing we need to do is divide by beta sub I. And now all we have to do to get expected return on the market by itself is add the risk-free rate to both sides. Now notice while I do this, I'm going to also switch the sides of the equal sign because we normally try to get the variable that we are interested in on the left-hand side. And so now we have the expected return on the market. Now let's try to tease out the most difficult variable from this security market line, R sub f, or the risk-free rate. And why is it most difficult? Because it shows up in two different places, and this one is inside a parentheses. And so the first thing we're going to do is distribute this beta over this parentheses. After we do that, we want to get the R sub f's by themselves. Now we need to factor out R sub f from this term as our next step to getting it by itself. Remember when you're factoring out to always divide all of these terms by the thing you're factoring out. And R sub f divided by R sub f is simply 1. Beta I times R sub f is just beta I. Now let's do one more step and divide both sides by 1 minus beta sub I. And as is my usual practice, I will put the variable of interest on the left-hand side. So we're just basically switching sides here. And nothing has happened to this side since this step. And so there you go. That's how we find the risk-free rate given the security market line. Here's a relatively simple idea that tends to give students a lot of trouble. Variance and standard deviation are both measures of dispersion about the mean from statistics, and we use them to measure risk in finance. And the relationship between the two is actually quite simple. Variance is just standard deviation squared. In fact, the way we write this in Greek is sigma a squared for variance and sigma a for standard deviation. And so you can even see it in the symbols that variance is simply the square of standard deviation. And so what does this mean? It means if you want standard deviation, you are simply going to take the square root of variance. Now, which one of these do we actually find more useful? We actually find standard deviation more useful because it's in the same units as the thing that you're trying to measure. In our case, it's usually stock returns. And so the unit of this standard deviation would be in percentages the same as our returns. And there's one other reason that we like to use standard deviation, and that is because we assume stock returns are normally distributed. And as long as I know the mean, or average, and the standard deviation, I can totally construct the normal probability distribution for any stock. Now let's talk about covariance and correlation. Both of these are measures of how one series of numbers moves with respect to another. For example, two different stocks' returns. Covariance of A with B we often write as sigma A comma B. This is the covariance of the returns of stock A with the returns of stock B. Now one might be tempted to look at this and assume that since it's just a single sigma, that it has the same units of standard deviation. That would be wrong. And the reason is that covariance is actually very closely related to variance. In fact, variance is just the covariance of a stock with itself. So if this said covariance of A with A, that would be the same as saying the variance of stock A. And so the units for covariance are the same as variance. Now, correlation, on the other hand, is unitless, and you'll see why that is here in a second. Now, the problem with covariance is that we don't know how to interpret it because nobody, regardless of how much education they have, can properly interpret percent squared. And so we're going to go with correlation. And correlation, you say, wait a minute, it's unitless, how can it be meaningful? And the answer is that correlation is bounded by -1 and 1. And so you can see on a scale of -1 to 1 how closely related the movement of these two items are to each other. Now let's talk about how these things are related to each other. I'm going to use the Greek letters. The correlation of A with B is equal to the covariance of A with B divided by the product of their standard deviations. Now you might also see this written as the covariance of A with B divided by the standard deviation of A times the standard deviation of B. You'll see lots and lots of different kinds of notation, but you shouldn't let it get to you. Oh, and by the way, we may also see this written as correlation. Let's solve it for covariance of A with B. The covariance of A with B is simply equal to the correlation of A with B times the standard deviation of A times the standard deviation of B. And this is going to become helpful later on when we look at the variance of a two-asset portfolio. So here we have the formula for the variance of a two-asset portfolio. This is a common one to see in a finance class. Notice that we have sigma squared over here indicating variance. The P is for portfolio. And this portfolio contains two stocks, stock A and stock B. And we have a new variable here, the X's. The X's are simply weights. If the portfolio is 40% A by market value, then XA would be 0.4 and XA squared would be 0.16. These things have to add to 1, XA and XB. So if this one is 0.4, this one must be 0.6. 0.6 squared would be 0.36. And we multiply those weights by the variance of the individual stocks. And then there's a final term, plus 2XA, XB, covariance of A with B. And this is a very common equation to see, but sometimes when you receive a problem with this, they'll give you correlation instead of giving you covariance. And so what do? Well, we can use substitution. Remember earlier we said that the covariance of A with B was equal to the correlation of A with B times the standard deviation of A times the standard deviation of B. So all we have to do is substitute in. We're going to substitute in this piece wherever we see this. And so we are simply going to drop that in. And so there we have the formula for the variance of a portfolio, actually the variance of the return on the portfolio, and all of this stays the same right up to here, and then we just simply substitute in correlation of A with B times the standard deviation of A times the standard deviation of B. Now once again, typically what we're being asked for is the standard deviation of the returns on the portfolio. And so I would need to take the square root of this variance on the portfolio in order to be able to get that standard deviation. Here we have the formula for beta. You may recall beta from the security market line. This is indeed the same beta. But how is it calculated? Well, we have a formula here for it. It's the covariance of the stock's returns with the returns of the market divided by the variance of the returns on the market. But sometimes we don't have covariance. Instead, sometimes we are given correlation. How would we handle such a thing? If you recall, we have this formula. Basically, I have just rearranged the formula for correlation to solve for covariance. And why am I doing that? Because I'm going to substitute in here for covariance. And once I do that, I have as follows. Now we can do a bit of canceling because we have standard deviation of the market here and we have variance of the market here. So I'm just going to mark out the two. And when I am done, I have correlation of the stock with the market times the standard deviation of the stock divided by the standard deviation of the market.